Touch the leg once again. Well, I must say that it's a matter of immense pleasure to be back with yet another video lesson, which will be a continuation of the earlier topic. And as usual, I hope that I find you in best of the health and in high spirit. Well, as a matter of quick recall, last week I had highlighted on the file operation based on binary files. I showed you a few programs with regard to how to insert a record and how to search for a particular name in the binary file. So today we'll continue further, specifically on how to update a certain name in the binary file, and then followed by how to delete a specific name in binary file, and then followed by another kind of operation based on binary files, but using another method or another way out using the pickle module, which will be a little simpler as compared to the earlier the method or the earlier way out. So without further delay, let's get started. Program F. Last week, if I just go up and check, I have this program which says searching for a name in binary file and displaying the record number. So today we'll write a program which will help us to make modification. So generally, whenever you deal with record, basically it boils down to four important operations. The first one is searching, the second one is adding or inserting a record, and then modification, and then deletion of the record. So these are the most common operation based on files. So let's get started. But before I write the program, let's just open the text or the file which has names like Nay, Leo, and Louis. So we'll write a program via which I enter an old name. Let's say I want to change Leo to Messi. So the old name will be Leo and the new name will be Messi. Alright, so this should be the situation. So let's get started. First things first, I need to have the record size defined, which will be 10, okay, as per the last program. But before this, I'll import the OS module, which will help me to use functions like getSize in order to determine the overall size of the file. And then I go further. So record size means the number of bytes which will be occupied by a single record or a single line or a single name. So even though Nay has 3 bytes, 3 characters, but it has 7 remaining spaces to make up for the overall bytes to 10. And then file size equals, we'll use this os.path, and then followed by get size, and then we need to specify the path of the file. So the path of the file will be c/temp/ and the name of the file is names.bin. Alright, so you need to take note of something. If I just get rid of this, okay, and then if I just have the file name, which means the file path will now be relative to the current working directory, which means this particular file names.bin must be in the current working directory or in the folder where the Python files are stored. So that was the difference between absolute file name and the relative file name. But as of now, I'll be using the absolute file path, which starts from the top level directory c:/ followed by temp/ and the name of the file names.bin. All right, and then in order to determine the number of records, it will be number of record is equal to int file size divided by record size. Okay, the file size will be like 30 and the record size will be 10, so the answer will be 3. So which means I have 3 number of records in the program. So basically, these are lines which we have dealt with in the earlier program. Now the next up is I'll have to use the with keyword, which combines the two related operation. I'll not get deeper into it because we have discussed already. With open followed by c:/temp/names.bin. okay, and then the file mode will be R plus B. So the B indicates binary and the R plus means read as well as write. So R plus will support both reading as well as writing operation. So why do we need both here is we need to read the old name and then check whether it's there in the file, and if it's found, we need to replace the old name with the new name. So this program deals with both operations of reading as well as writing on the same file. Hence the file mode has to be R plus. It means read and write. Okay, and then as the file handle or the file object will be F. So let's go further. So once I open the file of names.bin and then have it connected or have it linked to F, let's now prompt the user to enter the old name first. We need the old name first to check whether it's there in the file. If it's there in the file, where exactly it is, and then we need to replace that with the new name. So let's get the old name first. The question is, I want to change Leo to Messi. So the Leo will be the old name and the Messi will be the new name. So old name input, enter old name equals, and then old name equals old name dot encode. All right, this is important because I need to have it converted to the format which is retained in the RAM into the format which is used in the disk. So these two formats are different. So the encode function will help us to convert our format to machine understandable format, just to simplify the explanation. Okay, it's now time for the new name. New name equals input, enter new name. All right, and the new name should be modified as new name plus, and then followed by record size minus len of new name, and then this has to be multiplied with a space character. Okay, why am I doing this is the value of new name will be Messi. Messi has how many characters? 5 characters. MESSI, right? 5 characters. But when I write the new name, which has just 5 characters into the file, but the overall size of the new name in the file should be of 10 bytes. Remember, when the names they go into the file, they should have a uniform size of 10 bytes or 10 characters. So this new name will just have 5 characters as MESSI, but I want to concatenate 5 spaces as well in order to make the size of all the names to a uniform size of 10 characters or 10 bytes. So new name is Messi plus record size is 10, 10 minus length of new name is 5, 5 replication operator. So this space will be printed 5 times. So 5 spaces will be concatenated to the new name which has been just entered, will be entered. So that makes messy followed by 5 spaces. And then finally, I need to have this encoded to byte stream format. I repeat, it has to be encoded to byte stream format. Byte stream format means it's a format which is understood by the computer directly. So new name dot encode. Okay, so I'm done with the first part. I got the old name, I got the new name. It's now time to get on with the loop. For I in range, and then followed by num rec. Alright, so the value of num underscore record is 3. There are 3 records. 30 divided by 10, that makes 3. So for I in range of 3 means I will have the first value of 0 followed by 1 followed by 2. So it takes us to the individual names which have been stored in the file of names.bin one by one. In the process, we are on the lookout for the match with the old name. Okay, and then before this, we'll make use of 2 variables. The first one is position, which will help us to find the exact location where the old name will match up. So let's have the initial value of position as 0, and then found is equal to false. Initially, I have not found the data. The old name to be searched is assumed to be not found, hence will initialize found to false. All right. Okay, and then f.seek. Using the file handle of f, I advance, or I push the pointer to a location which is represented by position. The value of position is 0. So the seek function, seek is nothing but a function, will advance the file pointer to a location which is represented by the value of position, which is 0. So the file pointer will be pointing at the first character. All right, and then let's read the whole name. str equals f dot seek, f dot, and then followed by read, and then I'll specify the record size. Okay, I hope you are good with this. The value of record size is 10. So f.read will read in 10 number of bytes or 10 number of characters. So those 10 number of bytes or 10 number of characters will have NEY followed by 7 spaces. And then I check whether old name is in str. The value of old name is, it will be messy. It will be right. It will be Leo. It will be Leo. So we'll be searching whether Leo is found in Nay or not. The answer will be false, right? But before, let me just complete further so the explanation will sound better. Okay, if it's found, then first things first, what I need to do is I need to get the cursor back. Okay, I'll just complete this. Minus record size, and then I have 1, and then followed by f dot write. I'm going to write the new name if the record is found, and then I would like to print a message saying record updated. Okay, and then followed by I plus 1. Okay, and then the next statement will be, once I've finished with the f.seek, f.write, I now need to write found equal true. And then finally, I come out of the if block, and then I update the position of the file pointer by adding position plus record size. All right. Okay. And then I'll come out of this, and then let's say if, I'll just complete the program. If not found, then I would like to print a message saying old name is not found in the file. Okay, and then finally I'll close f.close. All right. Okay, I hope that I got the program correct. Let's first run the program and then I'll explain the program. All right, so let's run it. The old name, let's say, will be Leo, and the Leo will be replaced by Messi. Okay, it says record updated to. Let's go back and check. Let's go back and check whether it's updated or not. Okay, there you go. The Leo has been replaced by Messi. Okay, and the record updated is number 2. So let's keep this here and try to understand the program. Okay, this will be better. Just pull this up. Okay, so let's do this real quick. It should be cakewalk. I'll make a little change. All right, the old name will be Messi and the new name will be Leo. Since I'm getting to see the updated file, I would like to change the combination. Once again, I want to change Messi to Leo. So the user is asked to enter the old name. The old name will be Messi. So the value of old name will be Messi, which will of course be in encoded format or byte stream format. Enter new name. The new name will be Leo, L-E-O. All right. So the value of new name will be L-E-O followed by 10 minus 3 multiplied, replicated, the space. So L-E-O will be concatenated by 7 spaces. Okay, and then that will be encoded. So the value of new name is L-E-O followed by 7 spaces. Leo has 3 characters and then followed by 7 characters in the form of spaces. So that makes the 10 characters. Okay, so the value of old name is just MESSI, whereas the value of new name is LEO followed by 7 spaces. Okay, let's go further, and then the value of position is 0, the value of found is false. For I in range, the value of I will be 0 to start with. The value of num underscore record is 3. So 3 will not be included. The first value of I will be 0, followed by 1, followed by 2. The value of I to start with is 0. Okay, everybody, get your attention right. F.seek will advance the file pointer to the value of position, which will be 0. So the file pointer will be pointing at n. I repeat, f.seek 0 means the file pointer will point at n, the first character. And then f.read, the value of record size is 10. So starting from this, 10 bytes or 10 characters will be read starting from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So nay followed by 7 spaces will be read in str. Okay, so the value of str, to put it in simple explanation, the value of str will be nay. The value of old name is Messi. Remember, I want to change Messi to Leo. So the old name is Messi. The question is, the condition is Messi found in nay? Is the condition true? No. Okay, so the condition is false. If the condition is false, the if block which starts here and finishes here will be skipped. And this is not a part of this if. So this statement will be executed. Alright. So the earlier value of position being 0 will be added to the value of record size, which is 10. So the new value of position will now be 10. Okay, the new value of position will now be 10, right? So it then goes for the next value of I. The next value of I will be 1. Earlier the value of I was 0. Now this time the value of I will be 1. And then it gets in f dot seek position. The value of position is now 10. Is it? The value of position, the new value of position is 10. F dot seek position, the new value of position is 10. So the pointer will now be placed at the position of 10. So which means it's here. It will be pointing at M. Alright, starting from here, this will be the position of the pointer thanks to this particular statement. F dot seek, the value of position is 10. So it now reads 10 number of bytes. The value of record size is 10 as usual. It will now pick up the 10 number of characters or 10 number of bytes starting from here. So 1 2 3 4 5 6 7 8 9 10. So these 10 characters will be read and it will be assigned to str. Now this time the value of old name, which is Messi, will be found in str. The value of old name is just MESSI, but the value of str is MESSI followed by 5 number of spaces. So the condition is just MESSI found in MESSI followed by 5 spaces. The condition is true. If the condition is true, I need to make the modification. So I need to get the cursor back. I need to get the cursor back so that the new name could be written in its place. So for this reason, I am now using a negative value here. REC, the value of record size is 10, and I'm changing the sign. So which means if the sign is negative, the file pointer will move backward. If the sign is positive, the file pointer will move forward. But this time the program demands me to come back to get the file pointer back so that I could replace the old name with the new name. Alright, so what do you mean by this? Number 1 is it indicates the current position. So all in all, this statement means from the current position, I want to get the cursor back in a reverse order. If you have 0 here, the starting point will be at the beginning of the file. If it's 2, it means the end of the file. If it's 1, it signifies the current location of the file pointer. So in short, from the current location of the pointer, I would like to get the file pointer back by 10 bytes or 10 characters. So this statement will take the pointer back to M. Alright, so when you start to count back, it will start to point at the M. And then f.write new name. So starting from here, I would like to write the new name. Okay, the new name, the value of new name, I hope you remember, the value of new name is LEO followed by 7 number of spaces. That was the new name. Okay, even though if I just enter LEO, but this LEO will be modified to be concatenated with the 7 number of spaces. Okay, so that it will take up the entire quarter of 10 bytes or 10 characters. So coming back, so starting from here, the new name will be written. The new name will be written, and the new name will start as LEO followed by 7 spaces. And then followed by, I would like to print a message saying record updated, and the record number which is updated is I, the value of I is 1. Since the loop variable starts from 0, I would like to add 1 in order to make it understandable for us. For the layperson, 1 means the first, but when it comes to the index which are used inside a program, they always start with 0. So 0 for them, 1 for us. So in order to make the program little easier to understand, we add 1 to the I. So the value of I is 1. 1 plus 1 is 2. So in a way, I would like to convey this to the user that the record number that is updated is 2. Hence, I get this record updated 2. And then again, I go further. I update the value of position. You never know, the same name could repeat time and again in the file. It so happens in Microsoft Word you have this feature of find and replace. Okay, so in find we need to put the old word, to be replaced, and then little down there we have again a text box which will allow us to enter the word to replace the new word. So regardless of how many old words are there in the paragraph, each one of them will be replaced with a new word. So something similar to that particular feature, we have demonstrated, in the current program. So this is how, you should be updating the new name with the old name. So let's say if the name is not found, or we'll just run the program again. Say I want to change the Messi back to Leo. All right. So I'll just run this again. So this time it will be Messi, and then I would like to change it to Leo. Okay. If you go back and check, I'll get to see Leo here. Let's say PK is not in the list. So we'll run the program again, and then I enter PK here. Let's say, okay, press enter. PK is not found in the file. Why do I get to see this? Because I have not decoded this. Okay, so decode this, and then we'll run the program again. Let's say I would like to replace PK with PK not found in the file. So which means this condition will never ever be true. PK will not be found in Nay, Leo, and the Louis. Hence, hence these 4 statements will never ever get executed, and then which means the value of found will remain as false. It will never be true. It will remain as false. So not of found, the value of found is false, not of false is true. So this will be printed. PK is not found in the file. So this is how you write the program for the updating a name in the binary file. Let's move on to the next program. The next program is how to delete name in binary file. Now let's say I would like to delete Leo. Is it Leo or Messi? I'm a little confused. Okay, there you go. I would like to delete Leo from the list. So this is what the program says. So this time, all I have to prompt the user is for the name to be deleted. All right. And then there is no need of new name as such. So the logic of the program will be like this. I have the file by the name of names.bin. And then from names.bin, I would like to copy those names which do not match with the old name. So to put it in simple terms, since I have to delete Leo, the name to be deleted will be Leo. All right. So this Leo doesn't match with Nay. It doesn't match. So the Nay will be copied onto another file. And then again, it checks for the second name, which is Leo. The Leo matches with the name that is to be deleted. Hence, I will not be copying. I'll not be copying, Leo. it should not appear in the new file. And then it gets into the next name, which is Louis. The Louis, does it match with the Leo? It doesn't match, so the Louis will be copied. So all in all, if there is a match with the name to be deleted with the name in the file, if there is a match, that particular name will not be copied. If there is no match, that particular name will be copied. So this is the logic behind the program. Don't worry if you have not understood the logic behind the program, but once I finish the program, you'll be able to understand better.